Class. So this is part 2, and we're starting with angle of depression today, part 2 of 18.6. So we talked about angle of elevation, and if you recall, angle of elevation is when wherever it is that you're looking across at to something and then looking up, then we call that angle, because we're looking up, an angle of elevation. All right, now look at the picture here, and my arrow is going to move, so I don't want to draw anything on it. But this is the angle of depression. So that means like this lifeguard is up on top of his chair looking down into the water at somebody swimming. So when he looks down, then it's called an angle of depression. So his sight is from the horizontal, and I think it's going down about that far. From the horizontal is downward, and he's looking downward to the person down here. Okay. Now, the problem with that is, if you can see, let me move my picture over a little bit. If you can see where the triangle is, you can kind of look at this triangle. Now, sure, the triangle's there, but that angle where the arrow's pointing, which is the angle of depression, is not inside of that triangle, is it, right there? That's just not inside of the triangle. It's outside the triangle, even though that just moved inside the triangle. It's not really inside the triangle. So if that's moved to inside the triangle, then what we have to do is with these, I'm trying to make them, did that work? Those two lines become parallel lines, the sight, horizontal sight from the person, and then the ground, the line of the ground make two parallel lines. And that line of sight that you see in there, right there, that is actually a transversal. And so the angle being there inside the triangle becomes here inside of the triangle. So those are alternate interior angles in there. And those alternate interior angles that we use brings the angle into the triangle, but notice it's not attached to the person at the top looking down. It's not the angle right there by the person that's inside of the triangle. It has to be, we have to follow the rules of mathematics, and the rules of mathematics say those two angles aren't the same. But the rules of mathematics do tell us that alternate interior angles are the same measure. So that angle, when we're looking at the angle of depression, is not the one that we're looking at in the triangle. It's the one down that's the alternate interior angle to that one inside of the triangle. So that's the most important thing. Angles of elevation were really simple. It's from the horizontal up, so it's inside already that imaginary or indirect measurement inside of the triangle. But for an angle of depression, we place that angle inside of the triangle using alternate interior angles, which we learned in our parallel unit, parallel lines and transversals unit a couple months ago. So that's the most important thing. All right, so when we're looking at our angles of depression problems, here it says, for example 3, a person at the top of a cliff 100 feet tall sees a Gilligan's boat. So the fact that this person is here at the top of a cliff, we'll draw this person, and there's water coming up to the cliff, and a nice little boat. I'm sure you guys just love my drawings by now. So the person at the top of the cliff, 100 feet tall, sees Gilligan's boat. So this line of sight now is down to the boat. So he's looking down. Always happens. So there's an angle of depression of 10 degrees. So what we see is a horizontal that's going straight across from the person standing on top of the cliff, and with that person standing on top of the cliff looking across, that creates a parallel line to the ground where the water is. So these two become the parallel lines. This side is the other part of this angle, or the transversal, and this angle is 10 degrees, but then that means this angle down there is the 10-degree angle in our triangle that we're using indirectly to come up with a measurement to find out how far is the boat from the bottom of the cliff, which is right here. We don't know. Okay, one other thing I didn't write in, the cliff is 100 feet tall. So we know the cliff is 100 feet tall. Okay, I cannot write in this. Oh no, I took away the cliff he's standing on. I'm just going to write 100 feet and stay out of that side box because it keeps moving back down there. And we're erasing here. Crazy. All right, so that's 100 feet tall. We have a 10-degree angle inside of the triangle, which was the same alternate interior angle from our line angle of depression. And we have a side that we're unsure of here that's x. So when we look at the angle, this is opposite, this is adjacent, and O and A make tangent. If you recall, tangent is opposite over adjacent, TOA. So we'll have tangent always followed by the angle, in this case 10 degrees, is equal to 100 divided by x. So it's a switcheroo. We switch those two. X equals 100 divided by 10 degrees. All right, and that we are able to put in the calculator stage now that we can solve for x, and that is 567.1 feet, is it? Feet, yep. Look at the units in the problem. So 567.1 feet. So recall, once you draw the picture, the angle of depression is outside of the triangle. We use alternate interior angles to get that back inside of the triangle, and then set up the sides that we know and are looking for in order to come up with our tangent function to use to find the missing side. All right, so while standing on top of a hill at a ski resort, so here we have a hill. Lisa spots the ski lodge below, and I'm guessing they're thinking it's right here at the base of the hill. If the vertical height of the hill is 1,209 feet, okay, and here's whoever she is, Lisa, with their skis standing at the top of the hill. If the vertical height of the hill is 1,209 feet and the angle of depression, so from her, is 53 degrees down to that line that hits the lodge, then where does our 53-degree angle go? Here or here? Those are our two choices inside of the triangle. Of course, it's an alternate interior angle, so it needs to be down at the lodge. And then we want to know what distance must Lisa ski. So this is right here. This is her line of skiing. In order to reach the lodge. So that's x there. So what we'll do is we'll look at that's opposite and hypotenuse, so that's sine, always followed by the angle. 53 degrees is opposite, 1209 divided by hypotenuse, which is x. X is on the bottom, so again, it's a little switcheroo. We do x equals 1209 divided by sine 53. All right, 1209 divides sine 53. And that is 1,513.8 feet that she must ski down in order to make it to the lodge. All right, so that is angle of depression. Your next job is to go ahead and do the next assignment. When you see angle of elevation, then you'll know a little bit more about how to draw your picture. So here we have the Statue of Liberty, which I'm not going to be very good at drawing, but anyway, and then Sarah is right here standing, maybe she's sitting at an angle of elevation of 61 degrees. So that's going to be your picture. I just thought I'd let you see that. She's standing 166 feet. That's a good measurement that she can measure from the base of the statue. Actually, I think there's water surrounding it, but maybe there's 166 feet that she can stand away from the statue and still be there, and that's fine. So finding its height, so we're looking at this distance here. All right, so that's going to be opposite over adjacent, opposite over adjacent. So tan 61 is equal to h over 166, and then you can solve that. But that's just setting up your first one on your homework. Good luck with your homework. Have a great time. It's the last assignment before the review and the test and our last unit. Yay! Have a good day.